Alright, so for today's presentation, we are going to discuss something about the 8 fundamental identities that we have on or considering or involving trigonometric functions. So it is very important that we discuss these identities for it is very useful in simplifying expression which involves trigonometric functions, and so these identities can help you in finding or in determining the exact values of other trigonometric functions given a certain situation. Okay, so the 8 fundamental identities are actually grouped into 3, namely the reciprocal identities, the Pythagorean identities, and the ratio identities. So what we're going to discuss first is what we so-called the reciprocal identities. Okay, defining the 3 basic trigonometric functions, wherein the domain that we consider are sets of angles. We define sine function, or the sine of an angle, as the ratio of what? The ratio of the ordinate over the hypotenuse. So this is actually the definition of the sine function, considering our domain as the set of angles. Now, we also define cosecant function as its reciprocal, wherein the cosecant function of an angle is actually equivalent to what? Is actually equivalent to r over y, which is definitely the reciprocal of the sine function. So we can definitely say, or we can directly say, that a sine function or a cosecant function, let's start with the cosecant function, is actually what? Again, the reciprocal of the sine function. So we can actually represent cosecant function, as 1 over the sine function, since we have emphasized a while ago that is the reciprocal of the sine function. So we can definitely, or we can actually rewrite cosecant function as 1 over sine function. And on the other hand, we can actually represent sine function as the reciprocal of the cosecant function, wherein sine function of an angle is equal to what? Is equal to 1 over cosecant function of an angle. So that talks about the first reciprocal identity. Okay? And more so, if we're going to define the cosine function of an angle, wherein we have defined that as the ratio of the abscissa, or x, over the hypotenuse. And we all know that the reciprocal of cosine function is the secant function of an angle, wherein it is actually equivalent to the hypotenuse over the abscissa. And what do you call that? And applying the things that we have applied from the previous one, we can actually what do you call that? Represent the second function of an angle as the reciprocal of the cosine function, which is 1 over cosine function. Okay, cosine function of an angle. And on the other hand, tulad ng sinabi ko kanina, on the other hand, we can actually represent cosine function as the reciprocal of the other. Okay, and that is cosine function is equivalent to 1 over secant function of an angle. Okay, and lastly, since meron na tayong dalawang basic trigonometric functions, so gawin naman natin yung kay tangent function, and we have defined the tangent function as the ratio of what? The ratio of the ordinate over the abscissa. And we all know that its reciprocal is the cosine or the cotangent function of an angle, which is equivalent to ordinate or abscissa over the ordinate. And then again, applying the things that we have applied from the 2 previous concepts, then we can represent the cotangent of a function as the reciprocal, or as 1 over tangent function. Alright, so that is 1 over the tangent of an angle, or tangent function of an angle. And again, on the other hand, we can represent the tangent function of an angle as the reciprocal of the other, and that is 1 over cotangent function. Alright? So, this talks about the reciprocal identities. Okay? So, these are the identities that we have derived. Alright? So, please do remember this. Next is what we so called the Pythagorean identities. When we talk about the Pythagorean identities, of course, we are talking about the Pythagorean theorem. Okay, so let us put down here the Pythagorean theorem, wherein it says here that the square of the square of the abscissa plus the square of the ordinate is equal to the square of the radius, or the square of the hypotenuse. Okay, and we're gonna be deriving the Pythagorean identities in three conditions. First is for us to divide both sides by r squared, making this part of the equation 1. Okay, and that is, okay, sige, copy lang natin to. That would be what? That would be x squared over r squared. That is x squared over r squared, because we're going to again, we're going to divide both sides by r squared. So that is y squared plus over r squared, okay, equals 1. Alright, if we're gonna divide r squared by itself, then that will be equivalent to 1. And rewriting this is actually equivalent to x over the square of x over r. Again, the square of x over r plus the square of y over r. Copy lang natin to para di na tayo magta-type. The square of y over r is equal to 1. Now, based on our definition of trigonometric function, we can actually replace x over r and y over r. Since x over r is defined as the cosine function of the angle, then we can say that we can rewrite the square of x over r as the square of the cosine of an angle. So that is the square of cosine theta. And so, we can replace y over r as the sine function of the angle, meaning to say we have the square of the sine function of an angle. Okay? The square of the sine function of an angle. Okay, and that is equivalent to 1. We can actually rewrite this notation, or the square of the cosine of an angle, we can actually rewrite this as the cosine squared theta. Alright, pwede po natin siyang i-rewrite na ganon, cosine squared theta plus the sine squared theta, the sine squared theta equals 1. Okay, equals 1. Alright, yan, equals 1. So, this will be our first Pythagorean identity, wherein the square of the cosine function of the angle plus the square of the sine function of the angle is equivalent to 1. So, this is true to all triangles. Okay? Next, since this is the first Pythagorean identity, let's now move on with the second. What we're going to do is, since dun sa una nating condition, dinivide natin both sides by r square, what we're going to do with the other one is for us to divide it naman by x squared. Okay? Sige, copy lang natin yung Pythagorean theorem. Alright, and then, what we're going to do, the second condition is for us to divide it by x squared. Alright, so that is x squared. So, this would become r squared over x squared. Okay, so making this part of the, or making this expression equivalent to 1. Okay, and that is 1 plus y squared over x squared equals r squared over x squared. And then, we can rewrite that as 1 plus the square of y over r. So, same things goes with this, or y over x, sorry. The square of y over x. Same thing goes with what we had applied kanina, equals Sorry. Alright, ayan. Equals the square of r over x. Okay. And then what we're going to do is for us to substitute this by our trigonometric function. So we have defined y over x as what? This is actually the cotangent function. So that is equivalent to 1 plus the tangent function, sorry, it's ordinate over abscissa. So that is the square of the tangent of an angle. The tangent of an angle, okay? The square of the tangent of an angle is equivalent to, what about r over x? R over x is the reciprocal of x over r, and that is cosine, okay? So meaning to say r over x is a second function. So we have the square of the second function of an angle. Okay? So that is secant theta square. Okay, and again, we can actually what? We can actually rewrite this as 1 plus tangent squared theta. Pwede nandun po yung exponent, tangent squared theta equals the secant squared theta. Okay? And that makes our, okay? And that makes our, let me just edit this one. And that is actually our second Pythagorean identity. Okay? So we have just derived it from, of course, the Pythagorean theorem. Okay? So wag pong kalilimutan that secant squared theta is equivalent to 1 plus tangent squared theta. Okay? And the last one is what we're going to do is to divide naman all functions by, or all terms in the equation or in the theorem by y squared. So this is y squared, this is y squared, and this is y squared. Okay, making this expression equivalent to 1. So we have down there x squared over y squared plus 1 equals r squared over y squared. And what we're going to do is to represent this as the square of x over y. That's the square of x over y plus 1 equals the square of r over y. Okay? The square of r over y. Okay, and then by substituting the trigonometric function which define these ratios, that is x over y is actually what? X over y is cotangent. So meaning that is the square of cotangent of an angle. The cotangent of an angle plus 1 equals r over y is actually the cosecant function of an angle, or the square of the cosecant function of an angle. And then representing these terms or these notations as what? As the cotangent of the cotangent squared theta plus, okay, cotangent squared theta plus 1 equals the cosecant squared theta, cosecant squared theta. And that makes our third Pythagorean identity. Okay? So, always remember this because we're going to use these identities in simplifying or in their applications. Okay, so that makes our third Pythagorean identity, wherein cotangent squared theta plus 1 is equal to cosecant squared theta. And the last group of fundamental identity, or the 8 fundamental identities, is what we so-called the ratio identities, wherein in this group, what we're going to do is for us to consider the ratio of sine theta and cosine theta. Okay? Again, sine theta and cosine theta. And cosine theta. So first things first is for us to make sine theta as our numerator and cosine theta as our denominator. So that is sine theta over cosine theta. Okay. And then what we're going to do is to substitute it with the ratio which define these functions. Okay? So sine function is actually equivalent to what? That is ordinate over the hypotenuse, while the cosine function is the abscissa over the hypotenuse. And when we simplify this one, we actually have, or in simplifying this complex fraction, for what we're going to do is to multiply it with the reciprocal of its denominator, and that is for us to multiply it with what? The reciprocal of x over r, and that is r over x. That is r over x. And then when we simplify this one, makakancel na po yung r. Okay, and that makes what? And that makes y over x. Again, that makes y over x. And when we have y over x, that is actually the what we saw ko, or that's actually defined the tangent function of an angle. Okay? So our first ratio identity is that we can represent the tangent of an angle as the ratio of sine of an angle over the cosine of an angle. Alright, so that makes our first ratio identity. Okay, again, we can represent the tangent of an angle as sine of an angle over the cosine of an angle. And same thing goes if si cosine naman yung numerator natin at si cosine at si sine yung denominator. Okay, so copy lang natin to. We have down there, pag si cosine naman yung numerator at si sine yung denominator. Okay? Copy lang natin to. That makes x over r over y over r. Okay? And when we simplify that one, that actually is x over y. Okay? X over y, and this defines the cotangent of an angle. So we can definitely say, or we can actually represent cotangent of an angle as what? Cosine of an angle, or cosine theta over the sine theta, or the sine of an angle. And that makes our second ratio identity. Okay? Okay, so the ratio identity tells us that tangent of an angle, or tangent theta, is equal to sine theta over cosine theta, and the other one is that the cotangent theta is equal to cosine theta over the sine theta. Alright, it is very, again, as I have said a while ago, we can actually use these identities in finding other values for of trigonometric functions, and so with simplifying complex or complicated expressions into a single expression. Let us now apply the different fundamental identities in solving different situations. Let's say, for example, given that sine x is equal to negative 3 over 5, use the fundamental identities to find the exact values of the other trigonometric functions of x if cosine of x is greater than 0. So let us analyze this problem first. It says there that the sine is negative 3 over 5, meaning to say the sine function is negative. And we are also given the condition that the cosine of x is greater than 0. Meaning if it's greater than 0, then it is positive. So in what quadrant does this angle lie? Or does angle x lie? Wherein sine function is negative and cosine function is positive. So, saan lang po ba positive si cosine? That is quadrant 1 and quadrant 4. Pero dapat negative si sine. So, meaning to say, the angle lies on the 4th quadrant. Alright, the angle lies on quadrant 4. Alright, so this will be our guide. Okay? Now, using the identities, ang hanapin muna natin would be cosine. Alam ba dun sa mga identities na na-discuss kanina, yung merong sine at cosine, that actually is under the Pythagorean identity that says the square or the cosine squared theta plus the sine squared theta is equal to 1. Alright, and what we're going to do is just to substitute the values that we have on the problem. Since hinahanap natin si cosine theta or si cosine x, sige, gawin na natin tong cosine x kasi x yung given. Alright, what we're going to do is just to substitute. Okay, so cosine squared x plus, ano bang sign natin? That is negative 3 over 5. So, substitute it as negative 3 over 5. So, we have down there the square of negative 3 over 5 equals 1. And then, simplifying this, so simplify lang natin siya. That makes the square of negative 3 over 5 is actually equivalent to 9 over 25 equals 1. And what we're going to do para mahanap natin si cosine is for us to transpose this expression to the other side of the equation, making this cosine squared x equals 1 minus 9 over 25. Okay? And then simplifying that, we have cosine squared x. Alright, cosine squared x equals, so 1 is actually equivalent to 25, ano? So that makes 25 minus 9 over 25. And if we are going to simplify that, that makes cosine squared x as 16 over 25. That is 16 over 25. But since hinahanap lang naman natin si cosine, what we're going to do to eliminate this exponent is for us to what? For us to extract the both sides of both extract the root of both sides, making this cosine x equals the square root of, that would be the square root of 16 over 25. Now, if we are extracting roots, remember that we are extracting both positive and negative. But since on our problem, it says here that the cosine x must be greater than 0, then what we're going to do is just to extract the positive root. So, meaning to say, the cosine of x must be equivalent to 4 over 5. Okay? So, that makes our cosine function. That is 4 over 5. So, we are given already with the sine, the cosine. Hanapin naman natin yung tangent. Alright? Since using the fundamental identity, sabi natin si tangent function, pwede na, or sige, si tangent x, kasi x yung variable na ginamit natin dito, can be represented as the ratio of sine x over the cosine x. Alright? And since given naman na tayo nito, what we're going to do is just to substitute the values. So, we have tan x equals, ano ba yung sine x natin? That is negative 3 over 5. That is negative 3 over, alright? Ulitin lang, that is negative 3 over 5. Si sine x, that is negative 3 over 5. And then, si cosine x, na-solve natin kanina, that is 4 over 5. And what we're going to do is just to simplify that. That makes negative 3 over 5 multiplied by the reciprocal of the denominator. That would be 5 over 4. Alright, that's 5 over 4. And that will yields to what? So, makakancel si 5. That will make our tangent function equivalent to negative 3 over 4. 4. So, ito po yung magiging function value ng ating tangent function. Alright, that's negative 3 over 4. Alright? But since hinahanap pa natin yung tatlo pa, or the three more functions, since we already have an idea of the reciprocal identities, since yung basic trigonometric functions naman ay given, so we can represent cosecant, alright, using fundamental identities pa rin, ano? So, cosecant of x is actually equivalent to what? 1 over the 1 over sine x. Alright, and if we're going to do that, cosecant x would be equivalent to the reciprocal of sine x, and that is 5 over negative 3. So, that would be the value of cosecant x. Okay? Alright. Next is for us to look for the secant of x. Alright. So, let us look for the secant of x. So, the secant of x is equivalent to what? According to our reciprocal identity, that is equivalent to 1 over cosine. So, we have secant x equals 1 over cosine of x. And for us to do that, kunin lang natin yung reciprocal ni cosine of x. Kunin lang natin yung reciprocal ni 4 over 5. And that is actually equivalent to 5 over 4. And that makes the function value of the second function. Okay? And the last one is the cotangent of x. Alright? The cotangent of x would be equivalent to 1 over the tangent of x, which makes the value of cotangent of x equivalent to, or reciprocal ni negative 3 over 4, that is 4 over negative 3. Alright, so by using our different fundamental identities, nakuha din natin yung other exact values of the other trigonometric functions of x. Alright, so that is one application of fundamental identities. Okay? Next example. We are going to simplify. Simplification na po tayo. We are to simplify cosine squared theta minus 2 cosine theta plus 1 over cosine theta minus 1. Alright, so wala naman pong ginawa, wala naman pong sinabi na condition. So, we just simply simplify it. Okay? Kung mapapansin ninyo, yung numerator natin, okay, i-rewrite ko lang, that is, alright, that is, again, cosine, alright, cosine squared theta minus 2 cosine theta plus 1 over the cosine theta plus 1 or minus 1, sorry. Alright, so kung mapapansin natin, yung numerator natin is actually what? It is actually a trinomial wherein it can be what? It can be represented as the sum of two squares. So, if we factor cosine squared theta minus 2 cosine theta plus 1, that is equivalent to what? That is actually equivalent to cosine theta plus 1 or minus 1 multiplied by another cosine theta minus 1. Alright? So, this is somewhat an application of your algebra over cosine theta minus 1. Alright? So, in this case, so pwede na po nating masimplify by what? By, pwede nating i-cancel itong isang factor na ito, which makes the expression equivalent to what? That is equivalent to cosine theta minus 1. Alright? So, yan, sinimplify lang natin. We actually don't apply any fundamental identity, but then pwede pa rin naman. Alright, so let us have another example. Okay, so what we're going to do is for us to express this cotangent squared y plus 1 over sine y in terms of sine y. Okay, so paano po natin siya isi-simplify? Okay, so let me, alright, so yan, Na-rewrite ko na siya. And what we're going to do is for us to use the fundamental identities for us to express this in terms of y. Okay, so kung mapapansin natin, yung numerator is actually a Pythagorean theorem which is equivalent to what? Which is equivalent to cosecant squared y. Tama po? That is cosecant squared y. Okay, over sine y. Okay, so ang gagawin natin is for us to what? Is for us to simplify this by what? By making the cosecant squared y as, since alam natin si cosecant is the reciprocal of sine, so pwede natin siyang gawin, that is cosecant, alright, that is si cosecant, gagawin natin siyang reciprocal ni sine, that is 1 over the sine squared y. Okay, so using our identity. Okay, kasi dahil naka-square siya, dapat square din yung nasa ilalim. Over, that is over, alright, ulitin lang natin. That is 1 over the sine squared y over sine y. Okay, and for us to simplify that, let us just copy the numerator. Let us just copy the numerator, that is 1 over sine squared y, 1 over sine squared y multiplied by the reciprocal of the denominator, which is equivalent to 1 over the sine y. Okay? And if we're going to simplify that, that is 1 times 1, that's 1. Okay, that's 1. And then sine squared y times sine y, that is actually yields to the cube of sine y. Alright, or sine cube y. Okay, so we have just represented this expression in terms of sine y. Okay, and that is 1 over sine cube y. Okay?